Hi, welcome. This is a video about how to solve for an angle in a right triangle using trigonometry. This is the highly proficient level. And the big thing here is that they haven't given us a diagram. And so we want to draw one out and just draw, a random triangle. I use a random right triangle. Make an effort to make sure that one of them looks like it's at a right angle. Makes it easier. So now notice this, it says the hypotenuse is C is 15.4, and this is the hypotenuse, the one opposite the right angle. So I'm going to label that as 15.4. I'm also going to label it as HYP here for my hypotenuse. You want to call it C, that's fine. Typically this would be big C, this would be lowercase c. That's not super important right now, but if you want to label it, that's fine. The important thing is that you're labeling it as the hypotenuse. And then a leg B of 4.6. It doesn't matter which one you choose. Choose one. We'll just go with whatever. Let's say this is B here is 4.6. And again, this is in centimeters. This is in centimeters. If this is little b, then opposite that is big B. That would mean typically that this would be big A and this would be little a. We're not concerned so much with that. But it says to find the angle measures of the triangle. We're going to find all of them. We already know that angle C is 90 degrees. That's going to be fairly common. If they don't tell you that the right angle is something else, assume that it is that uppercase C. And so we're going to find, and you can decide. I'm going to go with A or I'm going to go with B. It really doesn't matter. So I'm going to go with A, and I'm going to put a little theta there just to help me remember. This then is adjacent because it's right next to A, and then I've already labeled the hypotenuse. It is true that this is the opposite leg, but I'm going to choose not to label that so that I can focus on these two that I do have. I have A and I've got H. And so I'm going to go to my mnemonic and go, okay, I've got so, ka, toa. And since I've got A and H, there's only one there that has that A and the H, and that would be the cosine. So that's what I'm going to use to write my equation. The cosine of theta, or if you would prefer to write A, that's fine. The cosine of A is equal to A over H. That's 4.6 over 15.4. And the inverse of the cosine is actually one that's just called that. A then is equal to the inverse cosine of 4.6 over 15.4. And whenever you do the inverse sine, the inverse cosine, or the inverse tangent, which are also called the arc sine, the arc cosine, or the arc tangent, they mean the same thing. What you're getting in all of these cases is an angle. And so this right here, if I put this in my calculator, it will give me the angle. One of the things you need to be careful about, and I wrote this in my other video, but here you goes again. Note, put calculator in degrees! Exclamation mark. Now we go over here. If you look, and I do, have you clear your memories before you start taking a test. So second function plus 7, 1, 2, and it clears the memory. But notice up here with my cursor, it now says radians, and that's true in the older ones too. But in the older ones, to see it, you have to press this mode button, and it just goes in. You'll see that the radian is highlighted, not the degrees. So if I move down, boom, boom, and then over to degree, I select it with the enter button. And now it's highlighted. And you can check that in the older calculators by hitting the mode button, see if it's in degree. You'll do want to check, otherwise you're going to get that wrong. So check that it's in degrees. And then go second function, quit the month. And then we're going to go up here and we'll say, the inverse cosine. Second cosine, it's got that little -1. So the inverse cosine of 4.6 divided by, what was it? 15.4. 15.4, and close the parentheses there and then hit enter, and it will give you back 72.62, yada, yada, yada. We want to make sure, like it says at the top of this paper here, that you're rounding the decimals to the hundredths place. So I'm going to go back here. A then is approximately equal to 72.62. If I look at the 2, next to it is a 0, so that rounds down to 2 because it's closer to 2 than it is to 3. So 62.62. 72.62. Is that what I said? 72.62, 72.62. Yes. So this is 72.62, and it's in degrees because it's an angle. So I'm going to go up here and write 72.62 degrees. And from here, I'm going to just use the triangle sum theorem to get B, because that's a lot easier. I could do the same thing again, and then, label this for B. This would no longer be the adjacent. It would be the opposite. And then I would say, if this is the opposite, this is the hypotenuse, then that's now O and H. I would use a sign. And you could do it that way, but it's not as easy as just saying, hey, what I've got is I got 180 minus the 90 degree angle, and then minus the 72.62 degree angle, and that would give us 17.38. So this is let's change that back to black. 17.38 degrees. Let me double check that that's what I got. Yes, 17.38 degrees, and those are your answers. That's how you do it. Okay, ahora en español. I'm going to make note here, so remember, 740. Okay, en español, dice, highly proficient, para encontrar un ángulo, given a right triangle, dado un triángulo rectángulo, with a hypotenuse, con una hipotenusa, of C equals 14.4 centimeters, de C, que es igual a 15.4 centímetros, and a leg of B equals 4.6 centimeters, y un cateto, es como lo llaman en español, cateto de B igual a 4.6 centímetros, find the angle measures. Encuentra los ángulos, las medidas de los ángulos del triángulo. Ahora, no teníamos un dibujo, así que lo pusimos, un triángulo, asegurando de que se ve como un ángulo rectángulo, que tiene un ángulo de 90 grados. Y sabiendo de que C ya es donde normalmente lo ponemos en el ángulo de 90 grados, lo ponemos, que es 90. Y de ahí A o B, no importa dónde lo pones, pero sí puesto de que dice que C, la hipotenusa es igual a 15.4, a eso lo ponemos. 15.4 ese es C, y es la hipotenusa. Entonces lo ponemos, es la hipotenusa. Y uno de los catetos, si yo pongo que A está acá, eso significa que B está aquí abajo. Y opuesto de B mayúscula es B minúscula. Y ese es el 4.5 que ha nombrado aquí. Entonces B es igual a 4.5 centímetros. Sabiendo de que tenemos CA sobre H. K. Sabiendo que tenemos O y H. Ay, perdón. No es O, perdón. Me lo estoy poniendo aquí. que eso es Z aquí, esto ya no es, no es opuesto de A, es adjacent, perdón, disculpen. Entonces, adjacent, eso es A y H, y eso es lo que tenemos, es A sobre H, tenemos el cosine. Escribimos que cosine de A es 4.6 sobre 15.4. Y el inverso de hacer el cosine es el inverse cosine, se ve así. Y eso es el inverse. Entonces, si A es igual a, el cosine de A es esto, lo que tenemos acá, A entonces es el inverse cosine de esto que tenemos aquí. Hay que asegurarse de que en esta nota dice put calendar in degrees. Hay que poner su calculadora en grados, en degrees. Entonces, si lo chequeamos, si dice degree, estás bien. Si dice radians, y normalmente sí se cambian a radians cuando lo estás despejando la memoria, pones second plus 712 y ahí en la memoria se despeja, pero también ahora dice radians, no está en degrees. Para eso vamos a mode y vemos aquí donde dice radians, vamos abajo, 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 radians, vamos a su costado, enter, ahora está seleccionado ese de degrees. Entonces vamos otra vez second y este mode otra vez para quit, que es salir. Y estamos aquí, ponemos second cosine, es el inverse cosine, y era, ¿qué cosa? 4.6 dividido entre 15.4, y eso nos da 72.62, redondeado al lugar de las centésimas. Eso es lo que tenemos. Entonces lo apuntamos y de ahí usamos el teorema de la suma de los ángulos de un triángulo. Siempre se suma a 180, ponemos 180, le restamos 90, le restamos el 72.62 y nos da 17.38 y ese es el último que lo ponemos aquí. Oye, pa'lante, sí se puede, sí se puede, sí se puede, sí se puede.